In this episode of Data Framed, a DataCamp podcast, I'll be speaking with Robert Chang, data scientist at Airbnb and previously at Twitter. We'll be chatting about the different types of roles data science can play in digital businesses such as Airbnb and Twitter, how companies at different stages of development actually require divergent types of data science to be done, along with the different models for how data scientists are placed within companies, from the centralized model to the embedded to the hybrid. Can you guess which is Robert's favorite? This is a hands-on, practical look at how data science works at Airbnb and digital businesses in general. I'm Hugo Bown-Anderson, a data scientist at DataCamp, and this is Data Framed. Welcome to Data Framed, a weekly DataCamp podcast exploring what data science looks like on the ground for working data scientists and what problems it can solve. I'm your host, Hugo Bown-Anderson. You can follow me on Twitter at Hugo Bown and DataCamp at DataCamp. You can find all our episodes and show notes at datacamp.com/community/podcast. Robert, welcome to Data Framed.
Thank you for having me. I'm super excited to be here.
I'm super excited to have you on the show to discuss all types of things about data science, but in particular, data science in tech and data science at Airbnb, where you are now, and Twitter, where you worked previously. But before we get there, I'd like to discuss you.
Okay.
What are you known for in the data science world?
That's a good question. So I think for me, I'm just like every other data scientist, but I guess when I was at Twitter, I wrote a blog post on Medium called "Doing Data Science at Twitter," and that was a reflection of my experience working as a data scientist at Twitter for 2 years. And I just thought that I learned a ton about data science, and I was really grateful for learning all these stuff, and I wanted to kind of share it. Originally, I actually wrote it as a reflection for myself, and so I didn't really want to share it. But then in the end of the day, I thought that a lot of the stuff there could be very relevant for other people, so I shared it. And very serendipitously, it got picked up by Pete Skomaruk, which was a former data scientist at LinkedIn. And he's kind of an influencer on Twitter. And so he shared my blog post, and it got shared by 2 other people. And then, somehow the post got, viral, and that kind of got my, blogging career going. And since then, I've written a few other posts, all related to data science. So I don't know. I don't think I'm famous, but many people have told me and that they found my blog posts helpful.
Well, I've definitely found your blog post very helpful. I mean, more recently, you've written one 2 years on, reflecting on your time at Airbnb also, which we'll get to. But I do think your blog posts have opened the eyes of a lot of people working in data science or working as data analysts or working as data engineers, or even people from other disciplines into the daily ins and outs of what it means to be a modern data scientist. And that's one of the really exciting things about having you on this show.
Great. Yeah, I agree. It's really important. When I started writing the blog post, I didn't really have anything. I didn't have any specific goals in mind. But then over time, I realized just how useful it was. I thought I was just stating the obvious. But then a lot of people gave me the feedback that they found the blog post very helpful because it helped them to demystify what data science is really about. In an environment where everyone talks about like modeling, machine learning, deep learning, it's really hard to understand what data science really is, and what it really is, especially in tech, which is our current the subject of our discussion today. And so I think really just sharing that information with people is a very useful thing for the community. Yeah.
So before we get into a detailed discussion about data science in tech, I'd like to know a bit about how you actually got into data science initially.
Sure, yeah. So when I was in school, data science was not really a thing. It was not really a profession. I studied operations research as an undergrad, and then later I studied statistics in grad school. And generally and broadly speaking, I have always been very interested in statistics, computation, and also data visualization. I was very deliberate, even I guess early on, I was kind of very deliberate about how I want to build my skill sets. And so I actually very much enjoy planning all my courses and curriculum. And so I started taking a lot of classes in those three areas. And then one summer, I came across a blog post by Nathan Yao, who is the author for a very great blog called Flowing Data. And in that blog post, he mentioned about, I think he cited this like Harvard Business Review article on, data scientist, the sexiest job of the 21st century or something like that. Something really like eye catching and even like clickbaiting. And so I just clicked into it and started reading about it. And then I read through his description, and I realized whatever he was describing, the data scientist, this particular profession or role that he was describing was very similar to kind of the skill sets. It involves the skill sets that I have been building. And so I thought that, maybe there are interesting industry opportunities that would allow me to continue to work on that domain after school. And so that's kind of how I got started.
And so these three specific disciplines or skill sets were statistics, computation, and visualization.
Mm-hmm. That's correct.
And what type of research were you thinking about, or what type of data sets were you looking at, or visualizing, or doing computation on? What interested you at that point?
At that point, I think it was, to be honest, I don't think it was anything specific. There are many areas that I was interested in doing, but I was quite interested in understanding using open data to investigate some of the more social issues. And so I didn't do much public work when I was in school, but I was very interested in like basically taking these like governmental data that is like buried in the bureaucracy, and just kind of dig them out, and then just trying to visualize these basic statistics in a way that paints a picture about how our society work. And it really, yeah, so that I would say that's probably the area that I'm most interested when I was in school. I mean, that's probably one of the reasons why I later joined a social network company, just because there's so many data that's being generated by people, and it really gives you a glimpse of into like kind of how people share information, how they use information. That's kind of what I was interested in.
Great. And so essentially, you were engaged in these practices of statistics, computation, and visualization, and then noticed that these, among others, had been rebranded or remarketed as data science in some sense.
Mm-hmm.
Yeah.
Oh yeah, I should bring one extra example. I think when I was taking a visualization class, one of the examples, and there are many examples, but one of the examples that really came to mind was, I think there was the Enron scandal, and then somehow they like collected
All the emails.
all the emails,
Yeah.
and then someone like geniusly enough to like basically parsed out all the email communications and then put it into a graph, and it shows you how like basically how people have been communicating up until the scandal broke. And to me it was just like so fascinating to see how people leave these like digital traces that allows you to see that really just it's another way of capturing the history that is otherwise not possible.
I've actually gone through a bunch of those emails because they are public, and there's all types of wacky, office romances. There's all types of really wacky stuff in there. And a couple of my old friends, they're digital artists, and they actually did a project with the Enron email set where you can sign up to their mailing list to receive these emails in perpetuity for the rest of, for the next 1,000 years or whatever it is.
That's great. That's great.
So my last question about what your history is, when you say computation, which is such an important part of data science today, we're not talking about pen and paper. We're talking about using a computer. Or what languages were you using back in the day?
Yeah, that's a great question, and I had a lot of thoughts to share on this very topic. But to answer your question, when I was an undergrad, I actually really hated anything computer related. When I was undergrad, I did pure math. So I did a lot of proofs. So I use a lot of pen and pencils. And I try to avoid as much as I can on doing anything computation related. It's not until So I think I learned MATLAB when I was an undergrad. I didn't really use it. And then it was not until grad school, I think, and there's one class where I think it's a stochastic optimization course where we were learning some probabilistic models, and I think it was Metropolis Hastings algorithm. I think I still remembered it. That's kind of besides the point, but like we were asked to do some simulation, and I just got stuck. I didn't know what to do. And then that's when I really started to realize there's actually a very huge gap in my education where we are moving into a world where there's just a plethora of data, and then there's so much data that can be leveraged, but you can't do it by hand. You have to really leverage computers to do these processing. And that's when I started to realize, okay, I really need to get better at data manipulation or computation in general. And so I pick up R to start with, and then over time I moved to Python. Nowadays, I've been using a combination of R, Python, Unix, basically tools that are relevant to solve the problems at hand. So yeah, it's definitely a really important area if you want to become a data scientist. Learning how to deal with data and how to do computation in addition to statistics is a very important skill to have.
And you found R is the way you entered though.
Yeah, R was my first language. R to me was kind of an interesting language. It was the language that taught me. And if you talk to other people, you probably will hear similar stories where a lot of the statisticians and I guess scientists, a lot of their introductory like programming language is not really an actual programming language, not like a general purpose programming language, but more a domain specific, usually scientific computation like language, like R or MATLAB. Over time, I basically learned more about computer science in general, just on my own to pick up other stuff.
Yeah, my trajectory is actually quite similar. And we're just about to get into conversation about data science in tech, but I just wanted to take a slight detour and
Sure.
talk about the fact that people used to do stuff by hand, right? I mean, Pascal, Fermat, I think it was Daniel Bernoulli who came up with the binomial distribution and the Bernoulli
Mm-hmm.
distribution. He sat around and I think the story is he flipped a coin 6,000 times and wrote and saw the distribution appear, then figured out the closed form solution to it. But we do
Wow.
Reverend Bayes did the same actually. But we do have such incredible computational power these days, and thank goodness, because of all the data that's coming through, we couldn't do any of that by hand these days.
Exactly, and you see a lot of these patterns emerge or reemerge in the statistical and even computer science world. You know, in statistics, Bootstrap was around for a long time, but like its real power wasn't able to be realized until there's really enough computation powers for people to run these resampling schemes, and then you have the world of neural network where that was invented like as early as I think the 670s, and it's not a new idea, but it's just like the computers wasn't able to do it. Nowadays it's like growing really fast because all the GPUs and all that stuff, and so it's definitely the interplay of statistics and computation. I think it's going to be increasingly important.
So let's jump in. From your experience at Twitter, your current work at Airbnb, I'm going to ask a pretty general question. I'm just wondering what, to your mind, are the biggest challenges currently facing digital business?
This again this relates to what we discussed earlier, which is computation. Specifically, I think as a startup, any business, digital businesses, like if you want to eventually scale, you have to start from somewhere. And it's actually very important to be able to build a data foundation for you to do any sort of analytics. And so by data foundation, I mean, setting up the data infrastructure. So that might involve things like, making choices of like, what database are we going to use? Are we going to use, put things on Amazon, on AWS? Do we want to use HDFS? All that kind of stuff, which I'm less familiar with, but like building a strong data infrastructure is very important. And then second, it's important once you have the infrastructure, then to build your data warehouse on top of it. And so this involves in basically taking your raw data, organize it, aggregate it, clean it, and then put it in a form that is analytics friendly, so that other downstream users can use. And so data infrastructure and data warehousing, I think, is really the bedrock of all kinds of analytics. And only after then can you move on and to do more fancy stuff like business intelligence, experimentation, or building data products. So data foundation, I think, is a very big challenge for many different companies. And that is something that everyone has to go through, and it's very important.
At a business like Airbnb, data foundation would be incredibly important in terms of storing information about properties, users, all of these types of things, right?
Yeah, exactly. And this work might sound trivial, but it's actually not. And a lot of problems would pose as a trivial problem, but it's actually not. So I think it was Monica Rogati. She was also a former data scientist from LinkedIn. She had a famous tweet and said that basically, like, the majority of data science is just doing counting, but doing counting in a smart way. And I feel like building data foundation is very much like that. In addition to data foundation, I think, or I should say, once you have the data foundation, then if you look at the trajectory of a company, once you have the product market fit, that's where you really want to start growing your company. And so, helping your company to grow and drive more adoption and find more users who love and enjoy your services is really a big part of what data scientists typically do to help companies to scale. So that's something that I work very closely when I was at Twitter. And if you look at all the top companies nowadays, there's inevitably a growth team that's focusing on driving growth, sustainable growth. Beyond growth, then once you really have the scale, then I think that's when you want to start optimizing your business. And I think that's really where machine learning and then data product personalization can help. They can make the product smarter, they can make it more personalized, and they can make the business more efficient. I'm laying out the challenges, I guess, kind of align with the trajectory of how a company will grow itself in the data space.
I think that's a really intuitive approach, and it leads to a number of questions. We've discussed the data foundations aspect briefly. I'm interested in growth and what type of data science questions or techniques arise when thinking about these growth challenges.
There are various ways to answer that. One is that I think growth is very much data driven because a lot of the growth work is, well, there are kind of good growth work and bad growth work. The bad kind of growth work are the so-called growth hacking, where you're very short-term thinking. You're just trying to provide short-term incentives for people to like kind of sign up for your services, and then they come and then they use it for a little bit, but then they don't really retain. Those are not the kind of, I don't personally, in my opinion, I don't think those are the good kind of growth problem to think about. I think the good kind of growth is you really think about the business. You really think about what is the values that your service is able to provide, and then thinking about what are the product changes that you can make to expedite the process in which your users can start enjoying the values that your service provide. And so these are typically more longer term thinking. But I should say that either whether it is for short term growth hacking or long term growth work, I would say experimentation is a very huge part of doing growth. And because you can't really verify whether your hypotheses are correct or not unless you run a randomized control experiment. And so when I was on growth, that was the period where I learned a ton about online experimentation. That's an area that's very important. I think there are a lot of other, I would say, techniques that Facebook use, which, well, both Facebook and Twitter use, that I learned a lot. So I think this is probably invented at Facebook, but there's this framework called growth accounting, where you broke down your active users into different segments of users. So new user, resurrected users, users who churn, and users who retain. And then if you kind of break down your business if you break down your active users by these segments, you can observe over time. Oh, are you actually increasing the share of new users, or do you have a leaky problem where your share of churn users are increasing? And that's a very informed view informative view telling you what is the composition of the users who are using your services.
So could you give me an example of an experiment that you did at Twitter that you found interesting or exciting?
That's a great question. I've ran so many experiments at Twitter. I can talk about the first project that I was involved when I first joined Twitter. It was a project that is less growth related, to be honest. So let me describe what it is. So basically, it was a project where as a social network, people get notifications and emails as they interact with our platform, and we had a hypothesis that a lot of our users are receiving all kinds of notifications, and they're getting fatigued by these messages, and some of them are more useful than the other. And so one of the things that we were trying to run is there a way in which we can identify a subset of email or push notifications which users don't really need to get, and because they have low value. But and we have a hypothesis that if we are able to identify the combination of that email and user set, then we can remove those emails from them. That will, one, help them to have a cleaner inbox, and two, it will still not hurt our bottom line. Like, people will still find value, they will still come back. And so there are some data science work going into it and figuring out what is the right combination. And then we ran an A/B test where we have a control group where users will continue to receive whatever notifications that we have in the system. And then we have a treatment group where we hold back certain emails from the users so that we respect the user's inbox. And then the end result for us is to compare the result of the engagement metrics between the control group and the treatment group, and to see if we are able to maintain the same level of engagements for users who did not receive those notifications. And luckily, it turns out that we kind of did the analytics right, so that we realized basically the users who are most active, they're receiving. For example, if I get a direct message or a tweet from you, it's very likely that I will get the same notifications on my push notification as well as my email inbox. So they're in some sense kind of redundant. And so if we can just basically remove one or the other, then that will make their inbox less cluttered, but then at the same time, they'll still get the message from other channels. So that's kind of one example where it wasn't really used to drive growth, but it was using A/B tests to respect our users' space and inboxes.
That's a wonderful example, and it's a great experiment. But one of the reasons I think it's so wonderful is because it's something we can all relate to, right? With the world of having push notifications come in. I mean, while I'm recording this podcast with you, I've got my phone on airplane mode for the obvious reason. Up next, we have a segment called Data Science Best Practices with Justin Boyce. Justin's a lecturer at Caltech, where he teaches lots of courses for biologists and bioengineers and helps them to work with their data. Hey, Justin.
Great to be with you, Hugo.
I understand you want to talk to us today about how you share data.
Yeah, I want to make a simple but important point. If you want to share a data set, make an informative plot that displays as much of your data as possible.
I totally agree with that, Justin, but that can't be the whole story.
You're right. It often is not the whole story, and there can be lots of statistical modeling and inference to be done. But the seemingly obvious notion that you should generate a plot that displays as much of your data as you can is often overlooked. All too often, I see research papers, figures in news articles, and when I was working in industry, internal memos that do not do this.
Really? What do they do instead?
Well, most commonly, people will report a summary statistic, like the mean or median, and sometimes a confidence interval. This is often done in text, not with graphical plots, and sometimes the confidence interval is not even properly described. There are often implicit assumptions of normality of the data and symmetric confidence intervals, that sort of thing.
What's wrong with that?
Well, there's nothing wrong with reporting summary statistics, provided you clearly define the statistical model and assumptions under which they were calculated. But when you don't plot the data, you can end up over-distilling the data to just a few numbers. An effective graphic tells so much more of the story. In a graphic, you can explicitly see what the measurements are, and importantly, how they might be distributed.
Can you give me an example of a good display of data?
Sure. One of my favorites was used to show how dominant Steph Curry's 2015-2016 basketball season was in terms of three-point shooting. This graphic was made by the Upshot for the New York Times. We'll link to it in the show notes, or you can find it by Googling Steph Curry Upshot. Anyway, the people at the Upshot collated all of the NBA players who were in the top 20 in three-point attempts in each season since 1980. They could have computed the mean number of made threes over all players and the standard deviation, and then said that Curry's season was 3 or 4 standard deviations above the mean. That distills it down, but does not really show the whole story. Rather, the folks at the Upshot plotted the cumulative number of threes made for all of these players during the respective seasons. This graphic is so much richer. It shows how the number of threes made by league leaders has been steadily increasing over time. And it effectively shows how completely anomalous Curry's season was.
Yeah, that's a great graphic, but it takes up so much more space than reporting a summary statistic.
Well, that is true. But your data are important. Show them some respect and give them space in your reports. I also think space constraints, at least for graphics versus text, are irrelevant. Reports, research papers, even news articles are distributed digitally these days. Space is essentially free. Beyond that, if you want to make a point with your data, it is worth it to make a plot. If you don't have the space for that, you might ask yourself how important the inquiry for which you acquired the data actually is.
So then, as a rule, plot your data.
Yes, it's a simple but effective rule. Give your data the space they deserve.
This has been a lot of fun, Justin. Let's chat again soon.
You bet. I talked today about the importance of just plotting your data. In future segments, I hope to give some examples of effective plotting techniques, such as B-swarm plots and empirical cumulative distribution functions. I'll see you then.
I'm looking forward to it. After that interlude, it's time to jump back into our chat with Robert. Talked about the three different phases: data foundation, growth, and machine learning. Where is Airbnb at now?
Oh, that's a great question. The answer is it depends. The business is organized into different product verticals, and some verticals are very mature, and some verticals are quite new. To give you an example, the homes business, which is kind of how Airbnb got started, is very mature by now. And then the trips business, which is a new product vertical that was launched just last year, where in addition to finding homes, you can find local guides who can help you to enjoy local-like experience. That particular business is quite new. And so depending on the phase of the product, depending on where it is, the focus on data foundation growth versus machine learning might be different. So on homes, the data foundation has been built and is still being built, but the data foundation for by and large is there. And we're continue growing the business. And there's a lot of machine learning and personalization data products that's being worked on for the homes business. Versus if you look at trips, really because it's a new product, a very big focus is to focus on growth. So it really depends on which product vertical we're talking about.
One thing that changed in your professional life when you moved from Twitter to Airbnb was a far stronger focus on machine learning, right?
Mm-hmm, that's great.
And what type of machine learning are you doing or involved in at Airbnb?
To give you a bit more context, when I was at Twitter, I was very much involved in product analytics, experimentation, statistical inference. And so when I transitioned to Airbnb, I made a pretty conscious decision to learn about other areas of data science. And I want to do more machine learning. And I want to do more sort of data, basically modeling, statistical modeling. And so I was very lucky in the past, I would say 2 years at Airbnb. I was able to involve in some media modeling project. And the one that I have been working on recently, early this year, is a project where we try to model the lifetime value of a listing when they first get booked on Airbnb.
And what's lifetime value?
Yeah, so lifetime value, you can think of it as, if you have a listing and you put it on Airbnb, you will hopefully start getting bookings And then over time, you will accumulate. Each time you host someone, you will get paid. And if you accumulate these payouts, then over time, these are the total sum of money that you're able to earn by participating on this marketplace. And so if we look far ahead enough, we will be able to calculate your lifetime value of your listing on Airbnb. And so that's what LTV, lifetime value, stands for. As of why it's important, for us, it's very important because in addition to having very strong organic growth, we're also trying to grow our business in other ways. And sometimes growing our business, which involves costs. And so what we want to do is to be able to optimize our growth acquisition channels, supply acquisition channels. And what we want to be able to do is to calculate for each channel what is the return on investment. So if we put in $1 to acquire listings from channel A versus channel B, how much money will we get back in return? In theory, we can just wait for a year or wait for a long period of time, and then we will get to really observe how much money each listing is able to make, and then we can calculate a return on investment. But from a business standpoint, in practice, we want to be able to make that decision of optimizing across different channels as early as possible because we want to be forward-looking. And so this is where the predictive model for predicting the listing lifetime value can be very, very handy. So by taking into account a bunch of signals like the location of the listing, their availability, what kind of amenities they have, what are their historical performance and all that stuff, then we can start to build a historical data set and then use that training data set to train a model and then to predict for future listings that are on board with similar characteristics, what are the likely returns for them. And then when we have those predictions, then we can start making these important decisions of optimization across channels a lot easier than just waiting for it for a year.
That's a really good example of having a machine learning algorithm or challenge or task feeding right back into business development, right?
Mm-hmm. That's correct.
And so that kind of leads me into my next question is, data science, especially for a company such as Airbnb, where there is so much data science can have such an influence on any decision anybody within the company makes. So I'm just wondering how data science is integrated into the business as a whole.
Yeah, that's also a great question. In tech, in Silicon Valley, typically companies organize data science team in different ways, and as far as I can tell, there are generally three models, and this might not be the only three, but these are the three broad categories or approach that I've seen how people organize data science teams or how they integrate into the business. The first one is called the centralized model, where you have a team of data scientists basically sitting together, working very closely, trying to solve very challenging problems. And then once they kind of solve it, then they will kind of push it, try to sell it to the rest of the organization to adopt them. And so it's a very centralized approach where people are really the data scientists are taking command and driving the roadmaps on how they will provide value for the organization. That's one extreme. The other extreme is what we call the embedded model. And embedded in the sense that you have a distributed data science team where data scientists are embedded with the product team. So just like a full stack product team, you will have perhaps a designer and a team of engineers, engineering managers. You will also staff a data scientist on the team. And the data scientist on the team, on that particular product team, is very much responsible for all the data related work for that product. So it could be doing opportunity sizing, it could be doing product analytics, understanding how the users use the product, it could be designing experiments, so to help and iterate a product. It could be building machine learning models for the product. It could be a wide variety of things. And so these are people who are very, very much embedded into the product and they know very well the domain of the product, but not necessarily on other parts of the product verticals. One extreme is fully centralized model. The other extreme is fully embedded model. And it has its pros and cons. And we can talk about it a little bit more, but the last model is kind of the hybrid of the two, where you have data scientists continue to be embedded with product team, but then you still have this functional team where data scientists do not report to like a product manager or engineering manager, but they report into a data science manager. And so that way you have data scientists all contributing to specific product areas, and they're really the product owner and experts on these specific product areas. But at the same time, they are able to enjoy the right level of guidance and career growth from their immediate functional manager. And that's called a hybrid model.
The hybrid model. So the answer to my next question may be business specific, but in your experience, which is the most successful, both on a business side, but also for professional development for data scientists?
Speaking from the experience of someone who have experienced all three, I actually think the hybrid model is the best. The issue with centralized model is that a lot of time you, as a centralized organization, you have to, despite doing very good work, you really have to push your work to other people. By people here, I usually mean like the product teams. But you can imagine it being very challenging because a lot of time, especially in technology companies, they went through either sprint planning or cycle planning, where they are always constantly developing on what to build. And that's a very rigorous process, and it requires a lot of attention and a lot of planning. So if you're not part of the team and you're trying to push your insight or even ideas or agendas for the other teams to adopt, unless you have that right level of organizational relationship, it's really hard for your vision to be realized within the product. And so I find that generally very challenging if you're on a centralized team. On the other hand, if you're in a company with an embedded model, I think that's the best way for your data scientists to provide immediate impact. But then I think the downside of that is there could be times where data scientists actually do not report to a data science manager. They report to either mostly into like an engineering manager, in which case the engineering manager might not know how data science work because it's such a new field, unlike engineering. And so to me, that end of the spectrum, the embedded model like really maximizes the utility of the data scientists, but then sometimes at the expense of their career growth. So I think that's why the hybrid model was created, which is to balance the two, like business impact and career growth. And so I personally really enjoyed the hybrid model.
It also, as you say, balances the trade-off between having a manager who can speak the language of data science with you, but also feeling like you have ownership over the decisions that are being made with respect to the work that you do.
Exactly. I think that's quite accurate.
We all know that digital businesses are amassing lots and lots of data these days, and for the past several years, there's been this buzz term, big data, flying around. Mm-hmm. I was just wondering what your take on big data is and what role it plays for digital businesses.
Yeah, big data is really a buzzword, just like I guess data science and deep learning and all these terms. And so it's kind of it's really hard to understand, sometimes characterize what big data really means. In my opinion, I think I'm sure a lot of people might disagree with me, but from the perspective of a data scientist or a statistician or a scientist, I think for us, big data really means that when you run into problems where either doing analysis or building a model, the data that goes into your work doesn't fit on your laptop. I feel like that's generally a pretty good test to judge whether you're dealing with big data or not. Or to put it another way, there are actually many, many business problems which can be solved without using big data. And this might be a digression, but if you consider a lot of the Silicon Valley top companies nowadays, people would build their internal R packages or Python packages where a lot of the work goes into making the R and the Python environment connect to the internal data warehouse so that you can just query data from the warehouse, pull it down to your local machine, and then do your analytics or analysis. And I would say a lot of the actual data science work actually can be done on your laptop. So I think big data is not the solution to all the problems that people encounter when dealing with data science. That said, I do think that there are many different problems really requires big data. In other words, really require you going above and beyond building your model on your laptop. And so, just again, taking my the example that I mentioned earlier on building listing level lifetime value model. We have so many listings on the platform, and we're trying to make predictions for all these listings, trying to make predictions by taking into account a bunch of signals that we have. This is the scale of the problem is really, really big, and it's not something that you can just easily crank or some model that you can easily train just in your local machine. And so that's really where you get to the big data territory, where you need to start really think at scale. What is the best way for you to build this thing in addition to beyond your laptop? And this is where like having a really strong data foundation team or a very strong machine learning infrastructure team can be really helpful, because those are the people who can really help us to operationalize these big models.
Exactly. And something you've spoken to there, which I really like, is the fact that these types of businesses have developed infrastructures which allow you on your end to act like you're working with smaller data. And a lot of the work with the big data is done on the infrastructure side. Let's now jump into a segment called Data Science Blog Post of the Week with DataCamp Curriculum Lead Spencer Boucher. What post did you enjoy checking out this week, Spencer?
This week I wanted to talk about a great blog post that hits on the relationship between data science and academia. I'll bet that a big chunk of the listenership on DataFramed either are or have been involved in academic research, just because academia has played a crucial role in the development of data science from its earliest days. But the best way for data science and academia to work together hasn't always been super clear. So Jake Vanderplas has summed up some of these issues really well in his blog post, The Big Brain Drain: Why Science is in Trouble. Even though he wrote it way back in 2013, it's definitely still relevant today.
So we'll definitely link to this post in the show notes. But what are the major issues that Jake identifies, Spencer?
So Jake correctly points out that as science becomes more and more data-driven every year, the ability to effectively process data is superseding other more traditional research skill sets. More and more, scientists must be broadly trained experts in statistics, computing, algorithms, and software. Sometimes it can begin to feel like domain knowledge is merely an afterthought, actually. Despite this shift, academia has actually been pretty slow to adopt incentives that encourage developing the data science aspect of academic research.
And why is that bad?
Well, it's bad because an academic culture that only rewards publications runs the risk of losing out on new, potentially game-changing tools like NumPy, SciPy, and scikit-learn. Researchers need powerful open-source technologies like these to advance the frontier of their fields, so there needs to be systems in place to reward time spent working on them. As an academic who's a core contributor to both scikit-learn and SciPy, Jake knows these pain points really well. Although a lot of progress has been made in the years since this blog post came out, there's still definitely a long way to go. The incentives for developing data science tools are just so much better in industry, where that skill set is rewarded with better pay and definitely higher prestige. To quote Jake, actually, some of the most promising upcoming researchers are finding no place for themselves in the academic community, while the for-profit world of industry stands by with deep pockets and open arms.
Does Jake propose any avenues for improving or solving these conditions?
Yeah, Jake's got several ideas in the post about how to prevent unnecessary brain drain of academics to Silicon Valley. One that I find particularly interesting is the idea of creating a brand new academic employment track that provides a tempting career path for open source software developers. Check out his post in the show notes for more.
Thanks for sharing this post with us, Spencer. If you dug that, listeners, make sure to check out next week's episode, which is a conversation with Jake Vanderplas himself. Jake's a data scientist, astronomer, renowned Pythonista, and open source beast. Jake and I will be chatting about data science, astronomy, the open source development world, and an array of other data-related ideas. Thanks once again, Spencer.
Yep, you got it, dude.
Time to get straight back into our conversation with Robert Chang. With all this data that businesses such as Airbnb and Twitter have, there's a huge massive possibility for social research, particularly with respect to social networks. What are your views on this type of stuff?
Yeah, it's actually very interesting. I find them fascinating, and to my understanding, I've never worked with Facebook, but I'm a big admirer of their core data science team. Their core data science team have done a lot of interesting research in trying to understand how information disseminates in network, and kind of basically how information dissemination influence people's consumption and sometimes even decisions, right? And so, to make it more relevant to our current events, we have heard a lot of things about fake news on Facebook, for example. And so it's really interesting to think about, like, when these ads are being shown on the network, how does that really influence people's perceptions, and how does that really influence their decisions? I think there's a lot of work that has been done by the Facebook core data science team and many other companies as well to study these kind of things. And to me, that's very fascinating, because before these, like, social network where they have this tremendous scale, it's really hard for us to understand these things. And so it's really, really exciting to leverage the data generated by these social network to understand some of the human behaviors at scale. But if I want to play the devil's advocate, I would say this area of research is not it's not entirely uncontroversial, right? There are a lot of interesting research that has been done that makes people feel uncomfortable. For example, I think the famous one from Facebook was they try to I don't remember the details anymore, but I think it was something along the line of they ran an A/B test where they kind of slightly changed the word choices of their posts, and they try to understand, or not changing the the words. I'm sorry, but like changing the sentiments of the posts that are being presented in newsfeed, and then they try to, like, measure the well-being of the people over time, and then they're trying to understand the implications. These are things that people sometimes can find very uncomfortable because it's somewhat, like, manipulative. I guess I'm sure that when they do these research, they have the best intention, but it's very important to be careful to do it in a way that is ethical, and doing it in a way that is not manipulative.
But this is a great point and a great question, because research labs historically have been held to certain standards with regard to experiments they can take with the general populace, right? So perhaps we're even thinking of a future in which big business and social networks and this type of stuff need to be held to similar standards, because, as you say, they perhaps have the best intentions, but it may not be up to them to decide that, right?
Right.
So, as we discussed at the start of this great conversation, you've written a number of blog posts which do a lot of things. One thing they do very well is they provide a history of your path in data science, and actually provide not only advice for aspiring data scientists, but reality checks for well-seasoned data scientists. So I was just wondering, what advice do you have for people aspiring as data scientists now in 2018?
Yeah, that's a great question. And as a sneak peek, I'm actually working on a series of new blog posts on data engineering. So if there's any piece of advice that I would give to aspiring data scientists, I think is to learn a little bit more about how to build data pipelines, also known as ETL jobs. The reason I mentioned that is because over the course of my career so far, and I have observed people who are able to leverage data engineering as an adjacent discipline are the people who are able to take on more ambitious and meatier projects over time or over their career path. And I think that's something that I think is perhaps under taught or under it's not really obvious to many aspiring data scientists, because there's so many buzz around, like, just building the newest and fanciest deep learning models, and so these, like, foundational skills are overlooked. If you look at our current education system, either professional or academic, I think there's generally not a very big focus on teaching people the end-to-end data science workflow. And the end-to-end workflow generally involves a lot of steps, and almost always in the beginning is to ingest your data, do a bunch of data cleaning, and only after then can you start doing analysis. And so how do you build your workflow in a way that you can have analysis ready data, or as we can put it, how do you put your data into a tidy data set? It takes a lot of work and takes a lot of time. And I think schools and even these professional boot camps generally kind of don't teach you that. They just give you pre-processed data set, and then they focus on like technique, they focus on algorithm, and you just kind of take that data as given and then you start building some models on top of it. But that's not really how data science works. And so I think it's very important to focus on learning that. And so yeah, I have a lot of thoughts on that part, and I'm still trying to organize them. But I think it's very important to get exposure to building data pipelines that will compute data for you on a recurring basis.
Well, that's a great sneak peek into some coming work, which I'm sure everyone's excited about.
Thanks.
And what else?
I think it's important to get exposure early on to the different type or different facets of data science work, because this field is still growing, and because this field is nascent and new. We have a labor market where you have a bunch of people who believe there is a need, and I believe, and I assure you, there is a need for talent for data, and there's the demand side. That's the demand side, and then you have people who are aspiring data scientists who are trying to become professional data scientists. So there's the supply side, and you have this labor market where supply is trying to meet demand and demand is trying to meet supply, and that's a great thing. But I think the challenging thing is that sometimes companies don't necessarily know why they're hiring data scientists for, and sometimes people who are aspired to become data scientists don't really know what are the right skills to build. And so, in my opinion, if you're a new data scientist, it's actually very important to not jump directly into areas which you think are data science. And most of the people, especially the ones that have graduated from university programs or even boot camps, are people who really, really want to do modeling. We really, really want to do machine learning, really, really want to do deep learning. But really, that's only a subset of what data science is really about. And so my recommendation is, instead of just jumping in or concluding that modeling, machine learning, deep learning is the only path for you to become a great data scientist, I think it's good to be a little bit more patient, sit back and observe what are the steps involved in building and working on an end-to-end data science project. And then from there, I assure you, you will learn a lot of things that are actually not taught in school, that are actually very, very relevant to your day-to-day work. And so, building ETL pipelines is one such example. Experimentation, experiment designs is another example. I think these are all very important skills to learn. And so for someone who is early in their career, I think it's important to be patient and then to learn all the basics. And then after then you can decide, okay, do I want to specialize? If I do, then I can dig in a little bit more and then learn and go more deeply.
And I think that's not only is that good advice, but you actually spoke to something which I think about a lot, which is the idea of data science as being what you referred to as a nascent field, something that's being born as we speak. So we're going to have to wrap up in a minute, but we've been speaking about modern data science, particularly in terms of digital businesses. I'm wondering what future data science looks like to you in the next 5, 10, 20 years, where this field will be going.
That's a great question. And it's almost like a prediction question, which
exactly. And you work in machine learning.
Yeah. And as you know, prediction is always hard. So it's hard to say. In my opinion, though, if I were to make one prediction, I think is that tooling around data science is evolving very, very fast. And it's continuing. I think the path of innovation is not going to stop. I think right now we're in a world where sometimes even doing the simple stuff is really hard because of the scale of the data and because of the knowledge that's required to command or use all these tools. It has improved a lot, but I think there's still a lot of rooms for improvement and people are working on it. And so I think in 5 or 10 years, a lot of these data cleaning and a lot of these ETL process can potentially be greatly simplified. And I think that would be a very exciting place to be, because then you can outsource a lot of your sort of nitty-gritty detail work to the machines. They can do it to you, do it for you, and you can spend more of your time thinking about a business problem, solving the right problem, and then making your solution impactful for the domain that you're interested in. One specific example of this pattern is also in machine. You also see that in machine learnings, where there's this like big movement of so-called auto ML, automatic machine learning, and you have companies like Data Robot, H2O, and a few others that are all kind of trying to work towards this world where they're trying to automate a lot of the kind of nitty-gritty detail for you. Or I should say, at least they're trying to automate some part of your workflow. And so, I don't know, I think the world will be interesting when we get there. And I always have like interesting debates with my coworkers on, when will we be replaced by machines? And it's hard to say. I don't think we will ever be replaced by them, but I do think that the tools will evolve a lot. And so I'm looking forward to the day that new tools are being developed and born.
I'm also looking forward to that day. And so as we move from modern data science into future data science, I'd like one final call to action from you. What should we be doing? What should we be learning?
My recommendation would be focus on the fundamentals and then don't stop learning. And so if I want to pick one thing for all data scientists to learn, I would say learn SQL. I didn't know SQL until I started working. And so it's entirely possible to learn SQL, and you will learn how important it is for all kinds of data science work.
Thanks, Robert. It's been an absolute pleasure having you on the show.
Thank you so much for having me.
Thanks for joining our conversation with Robert Chang about the role of data science in business at Airbnb and in tech companies at large. Robert told us about the different types of data science work required at multiple stages of company development, from laying the data foundation to data science for growth to then machine learning for making the product or products smarter. We saw that at Airbnb right now, there are even several products at different stages of development. We took a dive into concrete examples of data science Robert does, such as estimating the lifetime value of properties on Airbnb. And Robert also broke down for us the different models of how data scientists are placed within companies. Robert made a strong case for the hybrid model being his favorite. Make sure to check out our next episode, a conversation with Jake Vanderplas, a data scientist, astronomer, open source beast and renowned Pythonista, who'll join me to chat about data science, astronomy, the open source development world, and the importance of interdisciplinary conversations to data science. I'm your host, Hugo Bown Anderson. You can follow me on Twitter at Hugo Bown and Datacamp at Datacamp. You can find all our episodes and show notes at datacamp.com/community/podcast.